Hello, greetings. In this video, we are going to look at energy. So energy is the ability to do work. And energy is a scalar quantity. A scalar quantity means it has only magnitude and it is measured in a unit called joules. So in calculating energy, we don't need to state the direction. And we are going to look at the two main types of energy. One is the kinetic energy. So the kinetic energy, the symbol for the kinetic energy is EK. EK. Alright, and the kinetic energy is defined as the energy possessed by a body by the virtue of its motion or movement. So a moving object has a kinetic energy, and the formula for kinetic energy is half mv squared. The m stands for the mass, which is measured in kilogram, and the v stands for the velocity or the speed, which is measured in meter per second. Now, the next type of energy we are going to look at is the gravitational potential energy, EP. And the gravitational potential energy is defined by the formula EP is equal to mgh. Now the m stands for the mass measured in kilogram. The g stands for the gravitational acceleration constant, and gravitational acceleration constant, which is 9,8 on the planet Earth, and the h stands for the height, which is measured in meters. The height, which is measured in meters. So, to do a calculation on the kinetic energy, we use the kinetic energy formula. And to do a calculation on the potential energy, we use the potential energy formula. So now let's see how we apply these formulas. A 1,200 kg car is moving at 20 meters per second on a highway. What is the kinetic energy of the car? So now, the kinetic energy, that is what the question is all about, to calculate the kinetic energy. So now from the question, we can see that we have the mass, which is 1,200 kg. And we also have the velocity is given, which is 20 meters per second. So now to calculate our kinetic energy, we just have to substitute in the values to get our value, which is 240,000 joules. Now the next example on gravitational potential energy. A 2 kg ball is held 5 meters above the ground. What is the potential energy of the ball? Alright, we know that the potential energy is given by the formula EP is equal to mgh. So the m, which is the mass from the question, is given by 2 kg. And the height from the question is 5. and the gravitational acceleration is constant at 9,8. So if we do our substitution in, we get our answer to be 98 joules. Now the next question we're going to look at, or the next subtopic we're going to look at, is mechanical energy. Mechanical energy is the sum of gravitational potential energy and kinetic energy. So mechanical energy is therefore gravitational potential energy plus the kinetic energy. So whenever we have to calculate the mechanical energy, we need to know at that point what is our potential energy and what is our kinetic energy, to add those two values to get our mechanical energy. Now we're going to look at the law of conservation of mechanical energy. So law of conservation of mechanical energy: the total mechanical energy of an isolated system remain constant. So the total mechanical energy of an isolated system remain constant. So isolated system means a system with no external force such as friction or other air resistance. And if, let's say this is my height. If an object is lying above the ground, now this object at rest, it has the potential energy, the mechanical energy of this object at this point is the EP plus the EK. But before the object starts moving, its EK is equal to 0. So we can calculate the gravitational potential energy of the object, but its kinetic energy before it starts moving will be equal to 0. And when an object is on the ground, the mechanical energy of the objects on the ground, EP plus EK. Before the object reaches the ground, just before the object reaches the ground, its EP potential energy is going to be 0, and we can calculate the EK. So we use this formula to find this. We can use it to find the speed of the object at a certain point or the height of the objects at a certain point. So now we're going to take an example of a question on the law of conservation of mechanical energy. A bag which has a mass of 1 kg is placed on top of a 2-meter high table and then falls down. Calculate its velocity when it was halfway down. So we have the bag which lies 2 meters from the ground, and we want to calculate its velocity when it was halfway. So this happens to be our position 1, and at this point happens to be our position 2. So in an isolated system, the mechanical energy at any given point is the same. So now we have to say that the mechanical energy at position 1 is equal to mechanical energy of the object at position 2. And what is mechanical energy? This mechanical energy is the potential energy plus the kinetic energy that is at the first position. And the second position too is the same. Mechanical energy EP plus EK at position 2. And we can expand this to say the EP, or the gravitational potential energy, is mgh plus half mv squared at 1 is equal to mgh plus half mv squared at 2. So therefore, to do our substitution at the first position, we know the mass of the objects to be, we know the mass of the object at the first position to be 1 times the gravitational acceleration, which is 9,8, times the height, which is 2. The height above the ground is 2. Now plus the half of the mass, which is 1, and then times the velocity, which is 0, and then now we're going to add, we're going to equate it to the mechanical energy at position 2. So the mechanical energy at position 2, we have the mass, which remains constant, times the gravitational acceleration, times now the height at position 2 to the ground is 1 meter. And then we are now going to add the half of the m, which is 1, and then v is what we are looking for, so we say v squared. So everything here at this point, everything here gives me 0. So everything at this point will give me 0. And if I multiply whatever I have in this bracket, I'm going to get 19,6 equal to, if I multiply whatever I have in this bracket, I'm going to get 9,8. And if I have to multiply whatever I have in at this point, I'm going to get half v squared. So now I'm going to transpose this to the other side to subtract it to get 9,8, which is equal to now half v squared. So what I'm going to do next is to get rid of these 2 here. So to get rid of the 2, I can decide to multiply both sides of the equation by 2. So if I multiply this side by 2, multiply this side by 2, this 2 cancel this 2, so I'm going to have 19,6 equal to v squared. And then I'm going to take the square root of my answer to get 19,6, which is equal to 4,43 meter per second. So that is the speed of the objects when it was halfway below the ground.